PowerPoint. I should have gotten this loaded first. But while that's loading, let me say this. Sorry we're eating into 55 minutes of your review session, but here's something I have done. I have left all the other review sessions out there on YouTube that I've done in the past year or two. I don't teach this course often, so there's not many of them out there, but everything that I've had, I left out there. I usually delete when we do a class that's already out there. I'll delete the old one. These are not. So students in the previous sessions may have asked questions that you didn't get to ask this time. So you can take advantage of that and see all of those. And like you said, you can see this one also. So let me say this for the people who may be listening. I hope you've done your student course evaluations. Did all of you say you had? Yes, 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 Ethan? Yes, yes. Okay, good deal. Thank you. I hope all of you have. And what are you doing tomorrow? Voting! All right, good deal. Okay. All right. So, let's go. Any questions from either the multiple choice part or the short answer part? 29 on the on multiple choice? Okay. So we're doing the final review. Let me get my pen activated. Okay. All right. Final review, multiple choice, and what number did you say? 29. Okay. All right, good deal. And this is all your scratch work and everything, right? Okay, good. All right, now the short answer part, you write everything on this piece of paper, these pages. Okay, wait, that's not all. Okay, there's 4 pages. Okay, you can go back to the running around. Thanks. Okay, 29. We're going to have to do that every time the student finishes. So 29, this is page 4. Okay. Excellent question. I was hoping someone would finally get around to one of these. Here's the question. Find the domain of the function h. And here is h. h of x is equal to x plus 5 over 6x minus 42x squared. Okay?
This isn't stapled.
What's that?
It's not stapled.
No, I know. I realized the machine that I was copying wouldn't staple, so I didn't staple them. And I can't get my fingers to work. All right, and all your work needs to go on there, okay? Don't leave anything blank because I can give as much partial credit as I can. If it's blank, 0 partial credit. Okay. Find the domain? What in the world does that mean? Okay? Are you at all familiar with function notation? Maybe not. Okay. Here is the key for function notation. If this was a y here, you'd know what that was, an equation, right? Well, guess what? F of x, h of x, g of x, whatever that notation is, substitute and put y. That's what it is, okay? Now, but we just call it a function of, h is a function of x. Now, x is called the independent variable. Because when we were plotting things that had x, y's, what would I always say? Give me an x, right? So that's the thing you get to choose. That's the independent variable. Once you gave me the x, I plug it in, figure it out, and that gives you the y. So y is called the dependent variable, or h of x is the dependent. Okay? Now, the domain is the set of all possible values that x can take on. That's the input. Okay? Here's the way to think of a function. Okay? I wish I had time in class to do this. When I was taking calculus as a freshman in high school, in college, the first term, my professor, this is the first time I'd ever heard of the word function, and here's what he said. A function is like a black box, okay? Now, for those of us in science type thing, we sort of know what they're talking about with a black box. But basically, he may have even drawn the picture on the board. Let me draw on this. Why do that if I've got this great schematic? Okay, a function is like a black box, okay? 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 This is the function, h of x. What you feed into it are x's. Give me an x, do it. Put an x in there, turn the crank, and out comes h of x, or y. That's what it is, okay? And as soon as he said this, it made sense to me, because when I was growing up, I lived on the farm, and we raised pigs we raised chickens, we raised cows, we raised pigs, we had a garden. We just about completely ate off of the farm, okay? And it was good food too, by the way. But when we kill a pig, it would be the coldest part of the year, late January, early February. When we killed a hog, then, you know, they did all this stuff. I was too young to do much of it, but I watched it all. But then my dad, after they had done everything, came inside and started dressing it, cutting it into the pork roast or the pork chops or the ribs or whatever. But anytime he made a cut, if he had a little bit of stringy lean meat somewhere that didn't fit with it, he put it in a pile. And that pile just kept growing as he cut up the pig. And after a while, when he got everything cut and packaged and everything else, he had this pile of, you know, mostly lean meat, but, you know, little scraps and pieces. And then we'd set up the sausage grinder, okay? And that was my job, was to turn the crank on the sausage grinder, okay? And what you did, you put in those scraps of meat, and it would grind them up, and you put in the spices, the sage and the hot peppers and the, you know, whatever else you were going to put in there to flavor it. And so that then was the input. The domain of the function is all the stuff that you can put into it. The range is what comes out, okay? So those are what those two terms mean. Think of a sausage grinder if you've ever ground sausage. Everything that goes in, scraps of meat, herbs, seasonings, that kind of stuff, what comes out in the sausage, okay? So, when it says what's the domain of the function, generally our first assumption is all real numbers. That's usually a really good assumption for a few exceptions. Here's one exception to that, okay? Okay, where's the rest of it? Okay, I need everything. Scratch word, everything. What's that? Okay. And that. Okay. And all right. Now, here's the second part. On this part, do as much as you can. I grade everything that's on here. This is where your answer goes. This is where all your work goes. Anything that if you leave it blank, 0 points. If you do something and you're heading in the right direction, I can give you partial credit, up to 5 points. 5 points is for correct. Don't leave anything blank. 8 questions. 40 points. Huh? I need the other part. Okay. I need that part. Okay. First 2 pages. And there's the last 2 pages. Okay? And on this, no, you'll need more scratch work. Yeah. But write everything on here. That's what I grade. Okay? You got room on the front and back, so use it. But I need to keep your scratch work. Okay? So you can use front and back. But write down everything. They're 5 points each. If you leave it blank, 0. If you get the correct answer, 5. If you don't get the correct answer but move in the right direction, I can give you partial credit for it. So don't leave anything blank.
I found this out in hallway before.
What's that?
I don't know whose it is.
They may have fallen out of someone's hand. Okay, thank you. Okay. All ready for the second part?
Oh, we still need our finish line, right?
What's that?
Oh, we doing 2 separate screens.
This is the separate part.
Oh,
Yeah.
okay. I thought it was the same one.
I found some more part ones.
I need to staple the paper together.
Well, the copy machine didn't have staple capability.
No, I
so-
said I did. Like,
Yeah, well, I would have printed them. I would have requested it. Well, I always request them to be stapled, but the machine wouldn't work.
I got an English exam. You got another exam today? And then I got this speech Wednesday.
Okay. There's 1, 2, 3, 4. Okay, let me listen up. Yeah, there's 8 questions, 2 per page, and don't leave anything blank.
Okay.
All your work here. If you leave it blank, it's 0 points. If you get it correct, it's 5 points.
Okay.
If you fill out something and you're heading in the right direction, I can give you partial credit. So don't
Okay.
leave anything blank. Okay?
Thank you.
All right, so you heard all that?
Yeah.
Okay. Okay. Are you ready for the second part? Be sure you put your name. Write down everything on here. Use front and back if you need it. But it's 5 points each. If you leave it blank, it's 0. If you get the correct answer, it's 5. If you're heading in the right direction, I can give you partial credit, so I can use anything blank. Okay. All right. So our assumption is the domain is all real numbers unless there's some reason you can't use it in the domain. Is there anything that would limit your domain in that problem? What kind of problem is this? Say again? I'm sorry. What does this horizontal line mean? Okay, what were you saying? Okay, that's a good idea. So let's do that. Okay. And how would you factor the bottom? It's a great idea. Say again? Not really unfolding. You got common terms here. Okay, wait just a second. No. Okay. That's the first part. Okay. This is a short answer. 8 questions, 5 points each. If you leave them blank, 0 points.
Okay.
If you get the correct answer, 5 points.
Okay.
If you do as much work as you possibly can and you're heading in the right direction, I can give partial credit. I can give 1, 2, 3, or 4 points. So don't leave anything blank. Okay? All right. Say again? Okay, so 6x times No, 6x will go into 6x how many times? One time minus 7x times. Perfect. You have now factored the denominator. Now, the question is, why would you factor the denominator? It was a great idea. I would have had you done it later. Why do you factor the denominator? What is it about denominators? Specifically, what can they never be? 0! Okay? So now we have something that can never happen. We have 6x times 1 minus 7x cannot equal 0, right? Because you can't divide by 0. So, guess what that means? Either 6x cannot equal 0. It's not just either, both. And this thing, 1 minus 7x also cannot equal 0. Neither of those can equal 0. Otherwise, your denominator is 0, right? Can't have that. Well, what would make this equal 0? Divide by 6, and that gives you x cannot equal 0. Yes, okay, over here, what would you do? Add 7x to both sides. Just like you solve an equation, you solve an inequality, and this gives you 1 cannot equal 7x. So what do you do there? Divide by 7. And that gives you that x cannot equal 1/7. So, what is your domain? All real numbers except x can't be 0 and x can't be 1/7. Okay? Now, there's two ways you can write that. One way I suggest is think in terms of a number line. Okay? Yeah. Okay, because you told me here this factor would be 1 minus 7x, right? Okay? And then you say that cannot equal 0, right? Okay? And if that can't equal 0, you added 7x to both sides. You told me to. Somebody told me to. And that gave you 1 cannot equal 7x, right? Okay, then divide both sides by 7. I know someone told me to do that. And that gives you x cannot equal 1/7. See? Okay. All right. You need the second part. What's that? I'm sorry? This what? No. This is short answer. Yeah, I've been telling you that all term. Okay. Okay. On this, be sure you put your name. And there are 8 questions, 2 on each page, 4 pages. And they're worth 5 points each. If you leave them blank, you get 0 points. If you get the correct answer, you get 5 points. If you do as much as you can, some of them have multiple parts to them. Do everything that you can, and at the end, if you don't get the correct answer, but you're heading in the right direction, I can give you some partial credit. 1, 2, 3, or 4 points. You don't want to leave anything blank. Do as much as you can on every one of them. And you can use front and back. No scratch work on that. Put all the scratch work on that paper. Okay. So, on this number line, let's just put a 0 here. 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4, 5, 6. Okay. Okay. And what did we just say? X cannot equal 0, so we're going to put a hole there. Can't equal 0, and it can't equal 1/7. Okay, I'm going to put it right there. I don't have room to put it any closer. So what does that mean? All these x's here, good x's. Those few x's in between there, and by the way, there's an infinite number of them, those are good x's, and all the x's out here are good. So you can either say the set of all x such that x is not equal to 0 or 1/7 or something like that, that set notation, Or, and this book likes interval notation, either one of these will do, but you have to recognize both of them. That would be the interval from, out here it's going to negative infinity up to 0, but not counting 0, so we put a parenthesis there. Okay, we union that with everything from 0, not counting 0, so again we use a parenthesis, up to 1/7, okay? Union that with everything beyond 1/7, not counting 1/7, that's why we use parentheses, all the way to positive infinity. So those are the two ways to write the answer, either in set notation or interval notation. That second is called interval notation. What does this say? 29 says, x is the set of all x's such that x is not equal, look at that, number which? D. That's it. Let's see if that's what they have on the key. I know I have a key somewhere here. 20, I don't have it here. Yeah. No, that's all right. I've got it somewhere here. Oh, here it is. Nope, that's not it either. Here it is. Got it. 29. D. Got it. Okay. All right. Where's your scanning time?
You already turned all that in. That's the second.
Oh, that's the second part. Good deal. If you want to come see me sometime, I'll give you your other quiz and that kind of stuff too, because I passed them out, but y'all were already in another room.
We have another quiz?
Well, the ones you turned in last time?
Oh, I already turned mine in.
Huh?
I already turned mine in.
I know, and I've graded it, and I can turn it back to you. That's what I was saying. So anytime, yeah, well, if you see me, you can get it. All right, so you see D is your answer. See what that means? Okay, and just by the way, since we're asking this, what's the range of that function? What output values could it have? What's your first assumption? All real numbers, and that's going to be good for that one. Okay, they didn't ask it here, but that would be all real numbers. Okay, good question, excellent question. Sorry it was so interrupted in the answer. Did it make sense? All right, any others? 42 on multiple choice. Did you? You said 42 or 43? 43. I'm sorry? 42. Okay. Is that all your stuff? Yes. Okay. Okay. 42. All right. Can I erase this one? Okay, 42. All right. On this it says find the x-intercepts. And here's 42. 64, f of x is equal to 64x squared minus 32x plus 4. It says find the x-intercepts. Okay. You ready for the second part? Okay. Maybe not. Okay, thank you. All right. On the second part, be sure you put your name. And also, there's 8 questions. 2, 4, 6, 8. Okay? They're worth 5 points each. If you leave them blank, you get 0 points. If you answer them correctly, you get 5 points. Now, some of them have multiple parts to them, so do every part. Okay? This one has 2 parts. And anything you do to work this out, if you're heading in the right direction, even if you don't get the right answer, I can give partial credit. 1 point, 2 points, 3 points, or 4 points. Okay? So don't leave anything blank. Fill out as much as you can. Okay. All right. Now, there was f of x equals 64x squared minus 32x plus 4. It says find the x-intercepts. What in the world are the x-intercepts? Say again? Yeah, okay, on the graph, what about it, x-intercepts? Where it crosses the horizontal axis, right? Okay, and what's going to be true about every point on the horizontal axis? Okay, they're all ordered pairs. Everything on the graph is an ordered pair. What's the ordered pair? What's something in common for everything on the x-axis? The x's change, but the what? The what? What numbers? X-axis, yeah, the numbers change on the x-axis. Okay, remember what ordered pair is? X, Y. So the x is to be anything on the x-axis. But how about the y's? Y is? Second? Yeah, it's the vertical axis. Look, okay, this point right here. Okay, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, negative 13, 1, 2, 3, 4, 5. That would be the point, negative 13, 5. Right? Okay. Now, what would be true about every point on the x-axis? The what? Okay, negative 13 would be fine, but what would be the y? Zero! It doesn't go up or down, right? If you're on the x-axis, the y value is always 0, right? Y-intercept, what can you tell me there? What 0? The x is always 0. So if it's looking for x-intercept, the y is going to be 0. Well, what is your y when you have it written like that? I don't see a y on the board. F of x is equal to y. That's what you remember. So the first thing we do here is set that equal to y. Y is equal to 64 x squared minus 32x plus 4. Okay? And then we want y to be 0. Okay, so set that equal to 0. 0 is equal to 64x squared minus 32x plus 4. What would we do next? No. No, y, you've already substituted 0 for y. There you have an equation, right? How would you solve that equation? What's the L for? A factor, of course. And what would be the first thing you would factor here? Say again? I would do something simpler. Simplify it. Notice what you got? Say again? 4 factors out. Let's factor out a 4 to begin with. And what does that give us? Before we go into 64? Oh, pull out those black boxes, okay? How many? 16x squared minus 8x plus 1. Perfect, okay? Now, guess what? 4 can never equal 0, can it? So that's not going to give us an x-intercept. 4 cannot be 0. You can divide it out if you want to, and it disappears, okay? So, yeah. So now we're stuck with just that part. Now, what do we have there? How would you factor that further? Does any of you see something obvious, or you want to do it the hard way? Yes, but 8 won't go into 1. So you can't factor out an 8. Can you factor that? Yes. Yes. What would be a good first try? Say again? 2 by 8? 2x by 8x? That is a try. You want me to save us a little time? Okay. One thing to note here, this first term is a perfect square, isn't it? And the last term is a perfect square. So what I would try first would be, what's set of perfect square? 4x. Let's try 4x and 4x. And then where do you look next? Sign of the last term is positive. That tells you these two signs have to be the same. And since the middle one's negative, they both have to be negative. And then what's the only possible factorization for 1? 1 times 1. Now, foil that and see if it works. Okay, you ready for the second part? Okay. Unfortunately, I made copies of got enough copies of the first part, but I don't have enough copies of the second part, so I've got to find those. Where is it? I may have just given away. I sure hope I didn't. Yuck! No, here it is. Here it is. Okay. 1, 2, 3, 4. Okay. How many are still in the room where you were? Make a guess. 10? 7? Does that sound reasonable or more? Okay. Let me go make more copies. I'll be right back.
Where you went? This the one. That was my calculator.
Is that the word part?
What is that?
Yeah.
Is on like
Oh, you finished the word part?
is it more like wiring says next to this onion?
This?
Yeah. No, that's the short answer. The more the choice is more like the wiring says like we're reading one right here.
Oh, short.
Let's see what we got. We got determine the degree of the polynomial. Let's see, just have to add those together. We got factor, type-like term, simplified numeral expressions. We got a couple of graphs.
Okay, I might just take a picture of this.
Multiplying, rational exponents, simple equations, subtracting, and then a problem that ends with 0. I won't tell you what one is.
I just want to know like what subjects.
Stuff we never did before.
I know.
I see this.
Well, today we're going to be learning about rational.
Okay.
I'm going to be teaching a class today.
No, you should put it on pause because you are teaching the class.
I know it.